As you know, if you've watched any of my videos before, we love our friends over at Seattle's Museum of Flight, and they always provide us with some interesting guests. And of course, if you look at the museum, it is mostly a history of mechanized flight. But this time around, they are taking it all the way back to the earliest flyers. We are talking 65 million years ago. And so I am privileged to be joined by paleontologist Don Henderson. Don, I appreciate you joining us. And first, I wanted to ask you to tell us a little bit about your museum up in Alberta.
So I'm at the Royal Tyrrell Museum of Paleontology in Drumheller, Alberta. We're about an hour and a half drive from Calgary. And we have the best fossil museum in Western Canada. We are the place in the world to find late Cretaceous dinosaurs and marine reptiles. And my job title is curator of dinosaurs, but I actually do flying reptiles and the sea reptiles and geology stuff as well.
So since you have this great fossil collection, is there any particular one that you all are proud of?
Yeah, we've got several specimens which made it into the Guinness Book of World Records for fossils. We've got the world's best preserved armored dinosaur. Came from way up north, Fort McMurray. It's got the skin, it's got stomach contents, it's got the scales, it's got the armor, it's all in place. And if it wasn't found by a giant digging machine, we would also have the tail, but we've got everything else. It's great. We've also got the a plesiosaur, a long-necked sea reptile with the most known neck bones of any animal ever, 76. So we've got a lot of really good stuff here.
That is fantastic. So I just want to back you up to the first one quickly now that you said that, because you sparked my curiosity. I'm assuming that it had all the stomach contents and everything because it was frozen.
No, it was. So this thing comes from the early Cretaceous. It's about 112 million years old. And at the time there was no ice age, no polar ice caps in the Cretaceous. So it was all very mild. No, this thing was buried at sea, deep in a shallow sea that used to cover part of North America. And no, it wasn't frozen. It was cold when we collected it, but the ground wasn't frozen.
See, I just assumed, being, from the Great White North, that it was all under ice, but I have to remember it wasn't always that way. No. So what you are talking about here at the Museum of Flight this weekend, and I want to point out that is Saturday at 2 p.m. You'll find them they always do these things in the Boeing Theater, which is just past where you get the tickets and come in the door there. You are talking about pterosaurs.
Yes.
So you're the expert. Tell me about them, Don.
So the whole time there was dinosaurs running around on the ground. There was pterosaurs flying in the skies. My talk is called Over the Heads of Dinosaurs. And we have these dinosaurs and pterosaurs both appear in the fossil record about 230 million years ago in the Triassic. Dinosaurs stayed as land animals and diversified and were really successful. And pterosaurs became specialized for flight. And yeah, most people don't know much about pterosaurs. There's a huge diversity, and the fossil record for them has got really good in the last 30 years. Our understanding of pterosaurs is loads better, but we've known about them for over 200 years.
What do you think it was that caused them? I know this might be really deep theory, and I don't know if you've gone that far, but what might have caused them to evolve into a flying animal versus so many other dinosaur species that were limited to the ground?
Well, you've got to think that's a whole ecospace, a whole habitat that's not occupied. And flying animals, they talk about the cost of transport to get to where you want to go. Once you get up in the air, flying is actually pretty cheap. So you can patrol a large territory, find things to eat. You have no competition from things on the ground. So it's just another habitat that could be exploited. And there was no other large flying things at the time in the Triassic. So it was just an open area.
And these pterosaurs were the only flying creatures, you said?
For a long time. So the pterosaurs appear around 230 million. We don't see birds until about 150 million years. So the pterosaurs had the skies to themselves for about 80 million years. and then they overlapped with birds for another 100 million years.
So that brings up another thing, because when I was having this preliminary discussion the other day with Ted Hutter from the Museum of Flight, he had mentioned that what was once sort of a fringe theory about dinosaurs having feathers is now sort of gaining traction. So for days I've been dying to ask you about this now, Don.
Oh yes, we have evidence for feathers or feather-like structures on all sorts of dinosaurs. And we also have evidence for feather-like things on pterosaurs. And so given the close relationship between pterosaurs and dinosaurs, their common ancestor probably also had some sort of downy covering for insulation. You don't find the feathers on the really big things, like a giant long-necked sauropod or a 10-ton Tyrannosaurus. The last thing they want is insulation. They'll overheat. But small things, we've got lots of evidence for different kinds of feathers on different parts of the body from a whole range of animals.
And you mentioned that they were for insulation, so not necessarily there to help them fly.
No, feathers seem to have appeared. So if you look at the chemistry of feathers, like even in birds today and extinct ones, feathers are made of the same materials that scales are. And they're outgrowths of the skin. And so you can think that feathers probably started for display, they would have been colored and patterned. And then you would have realized that if you made your large fluffy scales much thicker, they actually help keep you warm. And we know that most dinosaurs were probably warm-blooded active animals. And if you had a naked skin, you would just lose all that heat and die of hypothermia. So it's better to have insulation. So it's thought feathers may have started as display, but then they turned out to be useful for insulation. And then if you grow the feathers on your arms really long, it turns out they make a really nice airfoil. And you can start to glide, and then you eventually move on to powered flight.
And, I've heard over the years that if you look at modern birds, they sort of still have things that might even emulate dinosaurs. Is that right?
Yes. All the anatomical features we see in birds, they inherited them from small meat-eating dinosaurs. So the famous velociraptors from the Jurassic Park films, that's the sort of animal. The first Jurassic Park ones, they were naked. They should have had feathers. But that's the sort of animals that everybody agrees that gave rise to birds. And they lived together at the same time. So you had things like Velociraptor and relatives running around on the ground, and you had birds flying over their heads, and pterosaurs.
That is just amazing to me. So let's talk about pterosaurs, especially when they were alone in the skies, because you mentioned it gave them an advantage in terms of hunting for food and that sort of thing. I would imagine it also gives them a defensive advantage too, would it not?
Yeah, you can just get away from predators really easily. And it's also, you think the first pterosaurs were small, maybe crow-sized or a little bit bigger. And we think that they were living either in trees or in rocky cliffs, so they could find safe place to have nests and raise young. And we also know some of these early pterosaurs, a lot of them seem to be specialized for eating fish. And you could just imagine them gliding out over the sea surface or a lake and snatching fish, same way some birds do today. We've also got some kinds that were clearly insect eaters. And there's one kind from the early Jurassic. It looks like a nightjar. It's a bird with a big mouth and bristles around its mouth, and it flies around at night, hoovering up bugs. So exactly the same. So again, flying insects were a huge resource waiting to be exploited by something that could fly.
So, and you bring up another good point that I didn't even think of, because, I'm assuming as a total layman here that when you're talking about pterosaurs, you're talking about one type of creature, but we're talking about multiple species here, right?
Oh, I think there's about 200 species now. And there would have been more, but their skeletons are extremely delicate. Most of the bone is no thicker than a postcard thickness. And so they need really special conditions to preserve them. and there's only a few places in the world where we get a really good fossil record. We've got a couple of bones, we've got a chunk of a brain case, we've got a wing finger here, but we really don't have much. A really good place is Kansas, because in the Cretaceous, late Cretaceous, there was this shallow seaway covering North America, and it was a shallow, warm, subtropical sea, and they've taken out 1,000 pteranodon. It's such a good place to preserve them because the really quiet, gentle conditions, and they'd sink to the bottom in the mud, and they wouldn't be disturbed. But like up here, most of our fossils are in flowing rivers, so you had to be big, or else you get destroyed or eaten. So pterosaurs need very special conditions, and there's only a few places in the world that have that.
Well, it sounds like we're lucky to find them at all. Now, you also mentioned there were some, that were maybe like the size of crows, that sort of thing. And I know we all sometimes think of, we mentioned like Jurassic Park and other movies over the years. We think of these big things. Did we get any pretty sizable ones?
Oh, yes. In fact, the fossil record is biased towards the big stuff because their bones are tough enough. So we've got many different kinds with wingspans, like 6, 9, 12 feet across. There's a really big one, guess where, from Texas, called Quetzalcoatlus, which some people think it had like a 25, 30-foot wingspan. But unfortunately, it's very incomplete. So we don't really know for sure. But elsewhere in the world, like in Eastern Mediterranean, they've also got very similar animals that are really big. And in Central Europe, there's another one. It's really big. The very last of the pterosaurs, the same time Tyrannosaurus was around, the last of the pterosaurs were huge.
So we're talking about could have the wingspan of like an eagle.
Oh, easily. Lots of them did.
Oh, that's just amazing to me. So go ahead. I'm sorry, Don.
Their wing construction was very different as well. Their wing wasn't made out of feathers. It was made out of a sheet of skin supported on one super long giant blast finger. I want to call it a super pinky. It's long. It's as long or longer than the rest of the arm. It's a totally different way of making a wing.
But still, they were obviously able to fly relatively easily.
Yeah, they were really successful. They were around for 180 million years, and they're found on all the continents, everywhere.
What led them to start to make their way out? Because it sounds like if they're overlapping with birds, would I be correct to assume that they are, probably one of the last dinosaur species to die out?
Okay, you shouldn't call them dinosaurs. They're related, but they're technically not dinosaurs.
Thanks for correcting me there.
There's lots of anatomical details. It's thought that some people like the idea that once birds came along, they were like a form of competition. And I think it's significant that we got into the Cretaceous, that the birds were diversifying rapidly and filling in all the smaller body niches, and the only things left were to become super big. And the big pterosaurs are bigger than any known bird. The largest living bird today is about 30 pounds. It's the Cory bustard, but a lot of pterosaurs were heavier, 40, 50 pounds. So there's the idea that maybe pterosaurs, to stick around, they had to find a new niche, and maybe it was the high body sizes as working as gliders and soarers instead of flappers in a forest.
50 pounds, that makes you wonder how they got off the ground, but obviously
Yes.
they managed. Those pinkies were very strong, apparently.
Well, they also had an awful lot of muscle in their forearms, and this flight membrane, as we call it, it goes from the arms, it goes down the side of the body and connects to the legs and between the legs. So they couldn't have been running to take off. The little ones, like a sparrow or something, they could have gone boink and jumped up. The big ones may have had to climb up a cliff or a tree and jump. But then there's this new idea from Mike Habib at University of Southern California. He thinks, what if they just used their arms, their muscular arms, and did like the ultimate push-up and basically launched themselves into the air using this giant super push-up. And they got themselves up fast enough, high enough that they had time to do one massive downbeat of the wing to get some lift and thrust and get going. All this is detailed in my talk. I've got lots of pictures just showing what would happen.
Well, and we don't want to have too many spoilers. I mean, this is supposed to be a preview of your discussion here on Saturday. But give us, you've touched on it here. Give us a little hint about what your agenda is for Saturday's talk.
So I start with brief introduction about the evolution of powered flight in backboned animals. And then I go into the history of our discoveries of pterosaurs and how we've learned and how we know what we know. And then I start to review some of pterosaur anatomy. And then the rest of the talk is showing how different kinds of pterosaurs lived, all the different environments, different diets, different flight styles. And then I have a controversial idea at the end, which some people really like and some people really hate.
Don't tell me the controversial idea. That's a no spoilers. I am absolutely a no spoilers guy. So we want people to go. And of course, we're going to be going there to see paleontologist Don Henderson. And Don will be at the Museum of Flight this Saturday. And it'll be at 2 p.m. Don, thank you so much for taking the time. Really appreciate it.
Oh, you're welcome.